Hello and welcome to the Unit 8 Section 4 video on systems of equations. So in this final section of notes we're going to talk a little bit about different types of systems. You are very familiar with already solving a system of two equations with two unknowns when you're dealing with two linear equations. You did that in Algebra 1 and we did it at the very beginning of this class. Well, now that we know more than just linear functions, we're going to do a little bit of combining of things. We're going to first of all talk about linear and quadratic systems. So remember, linear equations when graphed produce a straight line, quadratic equations when graphed produce a parabola. If the graphs of a system of equations are a parabola and a straight line, the system will have either 0, 1, or 2 solutions. And that's what an example of what all three of those would look like. You would have no solutions if they don't meet at all. One solution if you have, say, a constant meeting the vertex, or you could have some linear function that just meets what we call the tangent to the parabola, or you could have two solutions where the line just goes right through the parabola and you end up crossing the parabola in two spots. Knowing this, you can graph two equations and simply look for the coordinates where they cross. So let's do that with this first one. We are going to graph these two systems of equations. And you already are familiar with graphing parabolas and linear equations. They're both fairly straightforward to graph. So let's start off with this one. This is just the quadratic parent function. That one is fairly easy to graph because it's just your vertex at the origin. Then you got 1, 1. You've got over 2 up 4. And then you would go over 3 up 9, and then you would do the same on the other side. So that would graph your parabola. So we'll sketch that graph first. So there's my graph of my parabola. The other part that we're going to do is our line. So we're going to graph our linear part. We know we've got a slope of -1, and we have a y-intercept of 2. So we can go ahead and plot that y-intercept, which is right here, and then we're going to draw our line through there. And once you have your line drawn, then we just identify where the parabola and the line intersect. And so we have an intersection here, and we have an intersection here. And then from here we just write what our solutions are. So our solutions are -2, 4, and I'll write that in blue so it's a little easier to read. -2, 4. And then the other is 1, 1. Okay, let's take a look at one other example of this. So here we have a parabola that's not stretched or compressed, but it is translated to the left 3 and down 5. So that's going to put our vertex to the left 3 and down 5. Our vertex is going to end up here. So now let's just sketch out the rest of the parabola. You got over 1, up 1, over 2, up 4. And then you've got over 3, up 9, which would place us here. And then same on the other side. And then from here we'll sketch our parabola. So there's our rough sketch of our parabola. Now let's take care of the line. So we know we have a slope of 2. Our y-intercept is going to be at 2 as well, or at -2. So let's put our y-intercept here. And then let's sketch our line. So here we have our line. And you'll notice that this parabola and line do not cross. So therefore we have no solutions. Now we've learned how to solve a system of linear equations algebraically. we can use similar methods to solve systems with quadratic equations. Okay, so let's solve this system here. We've got x squared minus 4 and 3x. Well, if we use substitution, we can just set them equal to each other because y equals this and y also equals this. So let's just set each of these equal to one another. Then we'll move our 3x to the other side. And now we just have a quadratic to solve. We can factor this. Two numbers that multiply to give you negative 4, add to give you negative 3. That would be 1 and negative 4. And so our solutions for x would be negative 1 and positive 4. Now that we have our two values for x, we're going to break it up and substitute each of these into one of the two equations. And we'll go with the linear one because that one's the easier one to work with. So we need to find what y is, so we'll plug in negative 1 for x, and we'll plug in 4 for x. So y is going to be negative 3 for negative 1, and y will be 12 for x equals 4. So we have our two coordinates. Our solutions are negative 1, negative 3, and 4, 12. And you can graph both of these equations in Desmos or some other graphing utility and confirm that answer. Now let's talk about systems of quadratic equations, all right, where both are quadratic, and it's going to behave very similarly to what we just did. So you can have either two solutions, one solution, or no solutions, and that's provided for you what it looks like for each of those. No solutions, you have two parabolas that just happen to not meet. One solution, they intersect in one spot, and then two solutions, they intersect in two spots. So let's do one first by graphing. So again, we're going to graph some quadratics here, fairly straightforward. So here we have x minus 1, quantity squared minus 5. We are translated to the right 1 and down 5. So to the right 1, down 5, and there's our vertex. We're not stretched or compressed, so we can just simply graph the rest of the points. Over 2 up 4, over 3 up 9. And then same for the other side. Use your axis of symmetry to reflect the points over. And then we're going to sketch our line through this first parabola. So there's our first parabola. Let's use another color for the other one just to make sure we keep everything straight. So for the second one, we're going to be concave down, first of all, and then we're going to be translated to the left 2 and up 4. So left 2, up 4, here's our first point, and then we are concave down. There's no stretch or compression, so that makes the rest of this fairly straightforward. And then we're going to go down here. And we're going to reflect the points on the other side. And we'll go ahead and draw this line through. So there's the parabola for the second function. So now let's find where they intersect. So we have one here, and we have an intersection here. And so from here we just have to write the points of those intersections. So you got negative 2, 4, and 1, negative 5. And those would be your solutions to this system. Similarly, we can also find solutions algebraically by solving a system of two equations with two unknowns. Even though they're both quadratic, here's how you would go about doing it. So again, we have y here and we have a y here, so we can set those y's equal to one another. So let's do that. And since we're dealing with a quadratic, let's move everything to one side. So 2x squared minus x squared gives you x squared. Negative 12 plus 6 is going to give you negative 6x. And then 16 minus 11, that gives you positive 5. And then we see if we can factor this, and we can. X minus 1, x minus 5 equals 0. Then we know what our x values are. X equals 1 or 5. So like we did before, we're just going to plug in each of these values into one of the two. Let's use the second one since that's easier to use. So if we plug in 1 for x, we've got 1 squared minus 6 times 1 plus 11. And so that's going to be 1 minus 6 plus 11. So y will be 6. And then let's find out what y is for this other value of x. So we plug in 5 for x. And we evaluate this one. 5 squared is 25. 6 times 5 is 30. Plus 11 on the end. You add all those together and you get y equals 6 for this one. So your two solutions here are going to be 1, 6 and 5, 6. Now finally, I want to go through how to solve using technology, and more specifically, a TI-84 plus calculator. Technology is going to be helpful when you have to approximate a solution, if it doesn't come out nice and even like the examples we've done so far. So let's say we want to find the solutions for y equals the square root of x plus 6 and y equals 1 over x plus 4. We can approximate the solution using a TI-84 plus calculator. And here are the steps to do it. I'm just going to run through the steps so you see how it works. You can give this a try on your calculator as we go through these steps, and pause as needed so that you can make sure you have the time to go through these steps and enter in the information. So the first thing you want to do is enter both functions into the y equals. You'll do one for y1 and do another for y2. And so you should have a screen that looks like this. Then you go to the calculate menu by pressing second trace. That pulls up your calculate menu. And you're going to select number 5, which is intersect. Okay? That will pull up the graph. And you're going to set your left-hand boundary on your first curve. Then you're going to set your right-hand boundary on your second curve. And then you'll select a point somewhere close to where they intersect, and then hit enter, and that will give you the x and y coordinates of your intersection, and you would just write that rounded to however many decimals is required. If nothing is specified, then 3 decimals will do, the thousandths place. So here we have x is 4.311, y is 3.211, so you have the ordered pair 4.311, 3.211 as your solution as to where they intersect. And that's all there is to using technology. So this wraps up Unit 8, and this is the final unit for Algebra 2.